How's it going, guys? So today, happy Monday. What we're gonna do this week, this is the last lesson for Unit 1. You will have a Hawks assignment. I'm also gonna send out a quiz that I want you guys to take. And then from there, what we'll do is we'll hop into Unit 2 on Thursday and keep the train rolling. So 1.7, or 1.8 in our case, is rational exponents. All right, so recall, what are rational numbers? This is from that first lesson. All right, it's anything that could be written as a fraction, a repeating decimal. So example, if I had this repeating, that's 1/3. All right, it can also be -1, 0, any positive number. Okay, so decimal that ends, those are all examples of rational numbers. So let's compare the following expressions. If I did 7 to the 1/2 squared, all right, if you type that into your calculator, 7 to the 1/2, and then square it, you're going to get 7. Same way here, if I take the square root of 7 and I square it, I'm going to get 7. So these are the same thing, just written in different ways. So we can write square roots and nth roots as rational exponents. So that's the connection between the two. So that's what I talk about here. If n to the a, or nth root of a, represents a real number, where n is greater than or equal to 2 is an integer, then a to the 1 over n power equals the nth root of a. Also vice versa, if you have a -1, you can just put it on the bottom, right? Because negative exponents, remember, we move from the top to the bottom to make it a whole number. So like this one right here, evaluate each expression, use the definition of meaning, and explore the calculator keystrokes required to complete the value. So you can type a lot of these in on your calculator. So I can type 16 to the 1/2 on my calculator. It's also the square root of 16, which is 4. I can do the same thing here. This is the third root of 27, which is 3. But if you type in 27 to the 1/3, you're going to get the same thing. This one right here, the third root of -27, which is -3. Again, you can type it in on your calculator, get the same thing. This one, -16 to the 1/2. That's the square root of -16. Can you do that? Hopefully your calculator says no. Should say like error or something like that. However, I can have a negative exponent just to make it positive. I put it under 1. So this is the fourth root of 16 on bottom, which is 2. So the answer is 1/2. Same way here. Okay. So examples, what does a to the m over n mean? Some examples of this, if I had a to the 1/3, I can square it to get a to the 2/3. Or vice versa, if I had a squared, I can take it to the 1/3 power to get a to the 2/3. Which implies that the bottom number, the denominator, is going to go on the outside to be your nth root. The a goes on the inside, and we square it. Or you can square the number and then take the third root of it. They're the same thing. All right, so here's your correct definition of it that we just wrote out with numbers examples. But we're going to talk about the properties of exponents and evaluate this. So here's how I would do this. I would rewrite every problem. The 3 again goes on the outside. Okay, and then I would square my answer. So I would take the third root of 27, which is 3, and then square it. 3 squared would be 3 times 3, which is 9. So that's my final answer. If you have a negative exponent, right, you want to put it on the bottom to make it positive, and then just do the same work that we just did. So I would do 1 over, the 2 is going to go on the outside, so I would take the square root of 64, and I would cube it. Square root of 64 is 8. 8 cubed is 512, so my answer is 1 over 512. Same way here, another negative exponent. So I got to move it to the bottom to make it positive. and I can do the fourth root of 81 and then cube it. The fourth root of 81 should be 3, and I would cube it to get 27. All right? So here's what you're going to see on the Hawks. These next few examples are directly from the Hawks. So I would definitely make sure you understand these. Pause it if you need to, write it down, whatever it may be. So I'm going to give you something like this. If I multiply exponents to have the same base, I'm going to add those exponents. So I'm going to take 1/2 plus 3/4. Here's the thing. Whenever you add fractions, they have to have the same denominator. So I'm going to change this to 2/4. Okay, because I'd multiply the top and the bottom by 2. So now my answer is x to the 5/4. And you can literally write it like that, x to the 5. This next one, what you want to do is distribute this 1/3 to all of these. All right, so I have 125 to the 1/3, a to the 6 times 1/3, type it on your calculator, you're going to get 2, and b to the negative 1/12, because I would multiply 1 times 1, tops, and then the bottoms, denominators, 4 times 3. When you do this, let's simplify. The cubed root of 125, a squared, b to the negative 1/12. All right, the last step would be to simplify even further. The cubed root of 125 is 5, so I have 5a squared over b to the 1/12. Because I want to make that exponent positive, so I got to move it to the bottom. This one, what you can do, the negative 2/3 goes to both of those, so I have, before we do that, let's make it positive. To make it a positive exponent, I'm just going to flip the fraction and make it 2/3 now. So now the easiest step, let's apply the negative to the top or the bottom. You got to pick one. I usually apply it to the top, so I say negative 27 to the 2/3 over 125 to the 2/3. Because that 2/3 is going to go both of those exponents. That's your exponent rules. So now I would take negative 27, cube root of it, sorry, not cube it, cube root of it, and then square it. On bottom, I would take 125, cube root of it, and then square it. So the top is going to be negative 3 squared. The bottom is going to be 5 squared. When I do this, negative 3 squared is going to be 9. 5 squared is 25. While you guys are doing this, I want to add a section in here that says perfect cubes. Actually, I don't want to add it in there because you guys have seen it before, the perfect cubes and everything. It is on the last section's notes, so 1.7 notes. Okay? So moving on, the next thing would be something like this. You just work inside out. So I would take 105 divided by 5 to get z to the 21st. And now I got rid of that 5th root, so I have the 7th root. I would take 21 divided by 7 to get z to the 3rd. Okay? This one, notice the bases are the same, so what am I going to do with the exponents? I'm going to add them. Right? So negative 3 halves plus 5 halves is going to equal 2 over 2, which is the first power. So my answer is literally just 3y to the 3rd plus 5 to the first power. You don't have to write the first power. The answer they're actually after is just 3y to the 3rd plus 5. Don't let it intimidate you because it's got fractions and everything. You still have the same base, but you're adding the exponents. All right? Lastly, is something that looks like this. I want to go ahead and make my negative exponents positive, so I'm going to take x to the 4/3 is going to stay there. X to the 5/3 is going to move to the top. Z to the 4/5 is going to move to the bottom. This is z to the first. Okay. But I want to convert that to a fraction that I can add. So on top, I'm going to do 4/3 plus 5/3 to get 9/3, which is 3. So I have x cubed. On the bottom, I have 4/5 plus 5/5 is 1. So that's how I convert that to a fraction to get 9/5. And you can literally just write z to the 9/5. Lastly, you're going to see something like this. Perform the operation and simplify. Assume variables represent positive real numbers. So this one right here, notice the cubed root of 2x is probably what's going to end up being left over here. So negative 16 divided by 2 is going to be negative 8. So I could do the cubed root of negative 8. Think about how many x's I can pull out of here. There's 4 x's. I want 3 of them, so I make one pair. And then what I have left over is that cubed root of 2x. So if I simplify this, the cubed root of negative 8 is negative 2. The cubed root of x to the third is just 1x. I have cubed root of 2x. So now I have negative 2x cubed root of 2x plus 2x cubed root of 2x. If the square roots are the same, or the nth roots are the same, I can add those. Negative 2x plus 2x is nothing, so my answer is just 0. Okay? Same way here. Look at this. Cubed root of 2. That means I'm probably going to have the cubed root of 2 left over here. So let's simplify it. Cubed root of 16. I'm looking for groups of 3. Well, what do you know? You can make one group of 3 of 2. So on the outside, I'm going to put out a 2. And I have a 2 left over that's going to go on the inside. I didn't change anything over here. You still have to do 5 times 2, which is 10. 10 plus 11 is 21. Cubed root of 2. Again, same thing here. I have 2x left over. Probably going to have 2x left over here. So negative 64 divided by 2 will be negative 32. So I'm going to take the fifth root of negative 32. I have 6 x's. Looking for a group of 5. I can make one group of 5. So I'm going to say x to the fifth times fifth root of 2x plus 7x fifth root of 2x. This right here can be simplified into negative 2x fifth root of 2x plus 7x fifth root of 2x. So when I add these, I'm going to get 5x fifth root of 2x. And that would be your answer. Okay, another way to break these down, guys. So like if I did the fifth root of negative 64 x to the 6, you're looking for a group of 5. So let's say we did negative 64 down to 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. You see how there's 5 2's here? So that's what I'm going to pull out is that 1, 2. I have 1, 2 left over. Just be careful, there is a negative sign in front, so I'm going to also pull out a negative. And I have fifth root of 2 left over. You have 6 x's. I can make one group of 5, so that's why I pull out an x as well, and I have 1 x left over. Okay. Probably did this in algebra 2. If you like that method, you can definitely use it. I'm just telling you something that you will see a lot is how to break it down like this. and we'll talk about that as well. If you need any help with this assignment, it's going to be 1.2C Hawks. Please, 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 please. Actually, not 1.2C, 1.2D Hawks. So please, please, please let me know if you need help. I know it's not the easiest thing in the world. Other than that, have a good day, guys.